Are more AI agents always the solution, or should you sometimes stick to one agent? This is the purpose of this new research paper that was published by Google's team, and it's fascinating. It's called Toward the Science of Scaling Agent Systems. I highly recommend that you guys that are interested in deepening your knowledge regarding building agentic workflows and using multiple agents, read this out. But the goal of this short presentation is to share with you the gist of this research, which was published just a few days ago, like 5 days ago. As you can see, it's very detailed with a lot of interesting results and insights. But today we'll just share the gist, as I said. So basically, what this paper studies, obviously, AI agent systems or AI models that reason step by step. They use tools to add more predictability to the workflow. They interact with environments and they adapt based on feedback. Now, until not so long ago, there was this notion that if you add more agents to the automation, the likelihood of the results it increases the likelihood that the results will be better. So this research basically wanted to understand whether or not this is correct. So the core question was, when does splitting work across multiple agents improve results, and when does it make things actually worse? So first of all, what is a single agent? Is one AI agent powered by an LLM, has one chain of reasoning, one memory, one plan. The strengths are pretty straightforward. Maximum coherence, no communication overhead, so no tokens are wasted on communication. The weaknesses, it has no parallel thinking and no redundancy. In opposing to this, a multi-agent system has several LLMs. It can be the same models or different models. Each agent has his own reasoning, his own system prompt, etc. They do need to communicate and coordinate, which has pros and cons, and they can merge outputs between them. The strengths are parallel exploration, redundancy, ability to specialize, as I said, specific tools, specific system prompts, etc. The weakness is the communication cost, which isn't only in terms of cost per se, but also the downside of having a lot of tokens and wasting tokens. We will discuss this in a moment. Fragmented understanding and errors, the fact that errors can spread. In general, the paper shows that these weaknesses are often underestimated. As I told you, the notion is always, until now, based on what I'm observing, like the general notion is that the more agents you have, the more specialty you have, is going to be better, which is kind of similar to the Adam Smith idea that as society evolves based on specialization. I don't know if it's correct or not. Now, let's cover what they discussed in the paper. So the 4 benchmarks. Basically, they took 4 different benchmarks, realistic tasks, and each kind of testing different agentic behaviors. The first was a financial agent. What it is, it simulates a work of a junior financial analyst. It reads financial information, analyzes P&Ls, compares companies, produces structural conclusions, etc. It's very information heavy and reasoning heavy, and usually divisible. Basically, the tasks can be very easily divided. Now, in this comparison, I'm not going to share what exactly they did in the research, but because you can read it over here. But in general, the multi-agent system performed extremely well. The performance improvement reached over 80% compared to just using one single agent on these financial analyst tasks. So why this happens, why the hypothesis of why this happens: task split cleanly, sub results remain valid when combined, errors are easier to catch and correct. So this is very important, remember this. Next was a browser comp plus. It's another different evaluation. Basically what it is, it's a real web research simulation. The agent need to search the web, click pages, extract information, and combine facts from different sources. This task is highly unpredictable. Information is scattered, paths are uncertain, and the agent must adapt constantly. The results here were mixed. Independent agents with no communication performed badly, while coordinated agents slightly better than the single agent, but not significantly better. Now, why this happened? The hypothesis is because the parallel exploration does help, but without coordination, agents repeat mistakes. With too much coordination, overhead eats reasoning. So one thing to note is in this comparison, they had the single agent and they also had different types of multi-agency system. Multi-agent system with communication, multi-agent system with no communications, and different nuances of types of communications among the multi-agent systems. The next evaluation was a workbench, which basically is testing the agent performance on real business workflows. It had to choose among various tools, kind of a lot, between 10 to 16 tools, use them in the correct order, interrupt, understand the outputs, decide next steps. So many tools, precise sequencing, heavy planning around tool usage. Over here, the multi-agent system mostly did not help. Very small improvement at best, often worse than a single agent. And the hypothesis for why this happened, because tool usage requires full context awareness. When you split the context between the agents and suddenly you need to start tool calling, the decisions become fragmented, and the summaries between what the context doesn't move natively, it doesn't move in a proficient way between the agents, and then all the decisions start to become wrong, and this creates error, and the errors keep on accumulating and becoming worse and worse as time goes by. The next was PlanCraft, which is basically a sequential planning in simulated world like Minecraft. The goal of this task is to decide action sequences where each action changes world state. Future depends strictly on the previous. So basically, white matters because it represents robotic planning, game-playing agent, and any task with strict state transitions. In this instance, it was basically a disaster. All multi-agent systems performed much worse. Performance dropped between 40 to 70% worse than a single agent. Why this happened? Because this task is by nature sequential. It is state dependent, and it's impossible to parallelize. So splitting causes broken causal chains, conflicting assumptions, and overhead without benefit. Okay, so I kind of skipped the breakdown of the different agentic teams, but you can read about this in the research. Now, moving forward. Some principles. First of all, tool coordination trade-off. The more tools a task uses, the worse coordination becomes. Why? Because each agent gets fewer tokens, tool planning is fragile, message summarize complex tool interactions poorly. Example, one agent managing a 15-step workflow does better than 5 agents, each managing 5 steps with weak communication. Next, capability saturation. If a single agent already performs reasonably well in the task, adding more agents usually makes things worse. Why? The paper identifies threshold around 45% single agent success. Above that, coordination costs outweigh benefits. So a skilled engineer, an example from real life is a skilled engineer working alone, adding managers just slows them down. So if the single agent is able to produce the results with 45% success or above, it doesn't make sense to add more people to the team. So they call it the good enough effect. Next, the error amplification. Not all teamwork fails the same way. Structure determines error spread. Basically, independent agents multiply errors. Coordinate agents can catch errors between them. And central validation reduces damage but costs more time. So an example, independent agent amplifies errors by 70 times, multiplied by 70 times, while central coordination reduces that to only error rate of x4. So this is why, based on this notion, it's very important to have like a central source of truth and not allow the agents just to roam freely independently. Next is the predictive model. So I don't know if this is so important. Let me just summarize this very fast. Basically, the results explain why over half of performance, there is a big difference between performance in different types of agentic frameworks. Not frameworks, but agentic execution. So single execution versus multi-team execution versus team with coordination, etc. But this is this paper is trying to offer us when to use different types of hierarchy or formation. So basically the takeaway, the practical translation is use one agent when the task is sequential, the task involves many tools, or one agent already performs decently well. Use multiple agents when the task can be split cleanly, sub-results can be combined safely, and errors can be validated centrally. Avoid independent agents entirely for interactive tasks. So the mental model is AI agents behave like teams, not like parameters. Teams help when work is divisible. Teams hurt when coordination dominates. More people does not mean more intelligence. Yeah, I guess that's it. Let me think if there's anything that I didn't cover. I don't think that there's anything that I didn't cover. Let me see. Yeah, so they have had here, like, as I said, I think this is important. So they had independent group of agents, decentralized group of agents, centralized group of agents, and hybrid kind of a solution. Anyway, I hope you enjoyed this video. I think it's very, very important if you're building agents or multi-agent formations. If you enjoyed this video, obviously like and subscribe, leave a comment below with your thoughts, and until next time, keep on automating.